Hey guys, today I want to go over atmospheric basics. There are no guided notes for this unit, so we'll just go along and make sure that when you're taking notes, when you're writing notes down, that you're not writing down everything that's on the PowerPoint. You need to summarize and paraphrase what goes on there, because if you write down everything that's on the PowerPoint, you'll be taking a very long time to get this stuff done. So go ahead and learn now how to summarize and paraphrase both what's on the PowerPoint and what you hear me say. Alright, so we want to talk about the composition of the atmosphere. The term composition refers to a combination of distinct parts in order to make a whole. Most of our atmosphere is nitrogen, 78%. 21% is oxygen, and the rest are kind of trace gases. So you can see most of the air that we breathe in is nitrogen. Okay, what is ozone? Ozone has a chemical formula of O3. Atmospheric oxygen, which is what you breathe or what your lungs need to transfer throughout your body, is O2. Ozone just has an extra oxygen atom tacked on there. So 3 molecules of oxygen chemically combined. It's important because it absorbs UV light, because UV light can cause several problems like skin cancer for us. So the ozone layer helps to protect you from the sun's radiation. We're going to go through the levels of the atmosphere here, so help you with the atmosphere poster. The troposphere is the layer closest to the Earth. It contains most of the mass, including water. Weather occurs here. The stratosphere, which is the layer above the troposphere, is made mostly of ozone. And temperature will increase as you start to reach the top of the stratosphere. The mesosphere is the atmospheric layer above the stratosphere, and temperature decreases as you go up through the mesosphere. The thermosphere is a layer above the mesosphere, and very little air is present. The temperature can get as hot as 1,000 degrees Celsius. Then the exosphere is the outermost layer of the atmosphere. It contains light gases. What I mean by light gases are gases that are not heavy, such as hydrogen and helium. Okay, radiation, you should know what radiation is already, but we'll recover it here, is the transfer of energy through space by visible light, ultraviolet radiation, and other electromagnetic radiation. Here you can see some examples here. Conduction, again, is the transfer of energy when molecules collide. And convection, transfer of energy by the flow of a heated substance, either water or air. Here we can see the structure of the atmosphere. If you need to look at this further, be sure to pause. This can be very helpful in your atmospheric poster. So I'll go ahead and skip a couple slides here, and I'll let you read over this. This is a good description of all the different layers. I'll move this out of the way so you can see the bottom here. Moving along. Alright, so we've already talked about some of the solar fundamentals, but if you need a refresher, I'll go through these slides as well. Okay, these are some of the effects of light as they are, as it approaches the atmosphere and as it interacts with the atmosphere. You can see that here as well. Okay, and we'll talk about this a little bit later on in the unit, but the ban on chlorofluorocarbons protects the stratosphere because a main component of the ozone, or of this layer, is the ozone. CFCs break down ozone, and this is important because ozone absorbs UV radiation. We will talk more about ozone and the ozone layer and the ban on chlorofluorocarbons later. And these are unimportant. That's all for these notes, guys.